Make a start. Can everyone hear me okay? So my name's Stephen Haunts, and we're here to talk about how product manufacturing can help teachers to write better software. So I spend a lot of my time doing conferences and training. Write training courses for Pluralsight and another company called Skillshare. So if anyone's Pluralsight subscribers, you can find me on there. I've got 24 courses on there. I'm also a writer. I've got 3 books that I've written: The Art of Conversation, The Path to Freedom, which is about setting up businesses, and one which came out 2 weeks ago with A Press called Powerful Presentations, which is about public speaking and presentations in the workplace. Okay, so today we want to talk a little bit of a recap about traditional ways of working in software development. Then we're going to talk a bit about lean manufacturing, sort of a potted history of lean manufacturing. Then we can spend quite a bit of time talking about lean software development and what that means, with a particular focus on value stream mapping, which I think is a fantastic technique for people to get into the habit of doing with their businesses. Then we'll talk a little bit about Agile and Lean, and then we'll finish off with a little bit about Kanban and where that fits into the whole picture. So first of all, talking about ways of working. So before I go on to the next slide, I'm going to give you a little trigger warning in case this diagram gives you PTSD, because it normally does with a lot of software developers, so that's your warning. Our good old friend Waterfall. So, does anyone here still work in a Waterfall environment? No. Is anyone working at a company that's gone through an Agile transformation where you've ended up with iterative Waterfall, but called it Agile? That seems to be what happens in a lot of large organisations, which is probably a bit pessimistic, but it's actually probably what happens. Been there quite a few times myself. But this is, been since the 70s, been a traditional way of working in software development. You do big design up front, you do a big delivery at the end, and then you call it job done, and then you work on the next thing. Well, that's how it's supposed to work, but it never really does. But what we're more used to is agile software development with a particular focus on Scrum and methods from extreme programming. So the idea of agile is that your software evolves over time, and it's all about adaptive planning, evolutionary development, and early delivery. So, if you make a plan at the beginning, it's never going to be the same at the end. So you're always constantly adapting your plan, reacting to change. And that's kind of what one of the key tenets of Agile is all about, is responding to change over time. So it involves cross-functional collaboration and feedback. It actually requires you to talk to your business instead of just throwing documents over the wall at them, and vice versa. And then ideally you have frequent delivery of high-quality working software. That's kind of the dream. That's what we've been sold on. And in my experience of working in the industry over the last 25 years, in smaller organisations, it always works out pretty well. But when you do a big agile transformation in a large, 20,000 plus employee mega Godzilla corporate structure, it doesn't normally work out quite as well. But it gives the company an opportunity to spend lots of money on consultants, which is good for everyone. So just to illustrate that, then we have agile, which is lots of kind of iterative sprints and processes going on over time, as opposed to a big delivery all up front. So the hymn sheet that we all sing from with Agile is the Agile Manifesto. I'm not going to spend a lot of time going over it, but agilemanifesto.org contains the 4 core principles and tenets of Agile, which is kind of what everyone listens to, because there's a mistaken belief that when you ask someone what is Agile, they'll say Scrum. And that's not Agile. Scrum is just a project management template that you can play around with. And I take the controversial view that Scrum is something that you can change. I know some people take that Scrum handbook and they worship it as if it's some kind of religious text. But I believe it is something you can bend and change to fit the will of your company. If something doesn't work, you change it. That's kind of what Agile is about. It's adapting to change over time. But Agile is all about, it's the importance of working with people and collaborating, having people from your business working directly within your development teams. That's very important. They're the people you're building software for, so you should be collaborating with them. It focuses on working software, so at the end of the day, the only thing that matters is working software, delivering value to your teams. The collaboration, as we just said, and being able to respond to change. So if you're partway through a sprint and the customer comes along and says, the market's changed, we need to do this instead, that's fine. You embrace that. It's what Agile is all about. So you don't just cry and have to rewrite 600 pages of design documents. You respond. So this talk isn't specifically about Agile. It's just kind of setting the scene at the beginning. This is probably what a lot of people in here are used to. So is anyone here doing Scrum or an equivalent in their organisation? So you're working in some kind of iteration, you're working with your customers. That's what we're all used to. But there's kind of other stuff that you can do alongside Agile, which kind of helps you out. So what we'll do is we'll look a little bit back in time. So you may have heard these stories already. If you listen to .NET Rocks, you've probably heard them several times on there before. But lean manufacturing is not new. It's been around for a while. So Henry Ford of the Ford Motor Company released a Model T car in 1908. And what was kind of remarkable about how they built that car was the way they built it. It was a kind of a continuous flow production line, which is really quite new and unique at the time. But their process was what is known as a push process. So they're not manufacturing based on customer demand. So the company has set a limit of cars that they want to produce, and then they go through this production line to build that number of cars. So if the boss at the top says, I want 10,000 cars, that's the target they respond to. On the contrary to that, you have what's called a pull system, where you're not working to a limit that's set by the company, you're working to customer demand. So you have orders come in, you manufacture a car, send it out to that customer. A bit like what Tesla does, in effect. So in 1945, sorry if I pronounce the names wrong, but Kiichiro Toyoda and Taichi Ono from the Toyota company went to visit Henry Ford at his production line. And they were reasonably impressed with what they saw. You know, they'd gone there on a learning trip to sort of look at how Ford was working. And they were kind of impressed, but not totally impressed, because it being this push system. The problem with that is if you set an arbitrary number of cars that you want to manufacture, but you haven't got the customers to buy those cars, you're left with excess inventory just sitting in a warehouse or in a parking lot somewhere, deteriorating over time, because manufactured cars, if you just leave them, the materials deteriorate. So they weren't overly impressed. But whilst on that trip, they visited an American supermarket. And what they were impressed with, they were observing how the staff worked in this supermarket. And, you know, a customer comes in, they might buy, you know, a tin of tomatoes. The tin of tomatoes gets low on the shelf, which means they go out to the warehouse and bring another box out to put on the shelf. When the quantity in the warehouse goes below a certain level, they order some more in. So the entire production line, or the chain of stock replenishment, is driven by customer demand. Sell more tomatoes, need to put more on the shelf. Start running low in the warehouse, you order more in. So that is a pull system. The product is being pulled through the system based on the demand of the customer. And that was kind of where they got their value from that trip. It was visiting a supermarket and just observing how this stock replenishment works on the shelves. And this got them to come up with something called the just-in-time system. So we're not talking just-in-time compilers, although I suppose technically it is similar. We're talking about manufacturing value for customers based on their demand. So the beauty of this is, as I said, you don't have excess inventory waiting in stock, because that's classed as a waste. Buying excess inventory is expensive. It requires a large financial upfront commitment, and you're just potentially left with stock that you can't sell or can do nothing with, which means you either have to dispose of it or sell it for a loss. So when they went back to Japan, they started thinking about this just-in-time system. It kind of spurred this whole idea of how Toyota wanted to manufacture their vehicles. And they came up with the concept of 8 different types of waste that they want to eliminate in their manufacturing process. So the first one that they want to eliminate is defects. Same as in software, really. You know, if a defect makes it through into a customer's hands, that's expensive. If you think in terms of a car and there's a major defect, you have to do a product recall. Now, I'm sure you can all imagine how expensive that is if you've got to recall 200,000 cars back to your manufacturing plant. So any kind of defects that you can eliminate is saving waste. Overproduction, which is one we've just discussed, building more than you actually need or than you can sell, is classed as a waste. Having that excess inventory just sitting around. Transportation is a waste, so if you have to move your materials over a long distance to get them to where they need to be, that's considered a wasteful exercise. So if you've got a load of widgets that are in, a warehouse 50 miles away or 50 kilometres away, and you need to get them here for manufacturing, and you're constantly having to drive those widgets over to this warehouse, that's wasteful, because you've got people to drive the lorries, you've got fuel, all that sort of stuff. Why don't you just move those widgets permanently to this warehouse? Again, weighting. kind of follows on from transportation, but if you have to wait, so if you've got a production line in and you have to stop because you've got to wait for something to come from a warehouse to your production line, that is considered a waste and something that wants to be eliminated. And it goes on, so again, excess inventory, motion, moving things around warehouses, processing time, so if you've got some machines that are underperforming and taking longer to actually manufacture something than they need, is classed as a waste. And also, more importantly, as well, is the underutilisation of people. So if you're hiring people into an organisation but you're not using them to their full effect, then that is classed as a waste. So these are the kind of the 8 core things that Toyota wanted to eliminate from their production process, and their belief is that it would make them as a company more efficient and therefore would lead to more profits. So to do this, they have a few lean principles which they wanted to focus on. So the first one is generating value, obviously. You're building something for your customers. They're really all that matters. It's giving value to your customers. Same with what you do in your day jobs. They've got a principle of the value stream, which is understanding where any of the wasteful processes are in a larger process. And we're going to talk quite a bit about this later. And they've got the concept of flow, which is making sure that if you are manufacturing some software or some hardware, whatever, making sure you have no blockages in that pipeline to get your product out to the customer. That's called flow. If you think about your continuous delivery pipeline, if you check some code in, it goes through all of your tests, it gets packaged up, and then you want to go and deploy it, but one of your servers crashes, and you can't actually deploy that piece of software. You've gone through 90% of the process and it fails at the end. That's called a break in the flow, which is exactly a similar concept, but with a manufacturing production line. Again, the concept of pulling stuff through the manufacturing process was one of their core principles. So again, not setting an arbitrary level to manufacture to, like what Ford was doing. It's about understanding how many of these things you're going to sell so you know how many to build. That's why if you order something like a Tesla, sometimes you can be on a very long waiting list because they're building up, they're trying to gauge customer demand so they know how many to make. And a lot of cars get made at a particular time to deliver out to their customers. And the final one is striving for perfection all the way. Now, the way you get to perfection is you go through a process of continual improvement. Now, the Japanese call this Kaizen, which is quite a cool word. But really, this is about looking at your overall process and, doing a series of experiments to try and improve parts of your process continually. So you don't just do it once, you fix one area you think, right, I'm done. You're constantly looking over your entire business process and looking at ways to improve it. The most popular way of doing this is something called the Deming cycle, which is called plan, do, check and act. It's very simple. It kind of sounds like a scientific method in a way. So you have a plan of something you want to improve. So a machine that stamps out widgets from a sheet of steel is a machine that you've got, but it's not running at its optimal speed. So you put in a plan to try and fix that. And that plan might simply be just to measure how long it takes to punch these pieces of metal out of a sheet of steel, for example. And then if you turn it up by 5%, can you reliably run the machine and produce more stamped widgets? That could be your plan. So then you go and implement that plan, and you test it out. You check the results, and if the machine did successfully run with that speed increase, then you act on it. You make that the new norm. If it didn't work and you was getting lots of errors, then you might try another plan, which is to just reduce the speed slightly. So the Deming cycle is what that's called. It's just a fancy way of doing an experiment, measuring the results, and then implementing the results. Another technique is called the 5 whys technique, which I'm pretty sure was invented by children, because my kids are always constantly saying why whenever I ask them to do something. But it's a way of getting to a root cause of a problem. It's very simple. You just ask the question why 5 times. And there's a really good example here, taken from a website called the businessanalystjobdescription.com, a bizarre website, but it's got a fantastic write-up on this. So I borrowed this example from them. The URL's at the bottom if you wanted to read it. So we've got a problem. So the conveyor belt on the main production line has stopped. So why? First why. The conveyor belt has stopped. The main pulley responsible for rotating the belt is not functioning properly. Okay. So why is the pulley not functioning properly? Because it's not getting enough power from the motor. Okay, interesting. Why is it not getting enough power from the motor? Because the motor stopped working. Why has it stopped working? Because the motor winding is burnt out. So why have the windings burnt out? Because the motor was loaded beyond its capacity. Okay, this actually has 6 whys, but why is the motor overloaded? So the instructions about the motor's maximum load were missing. So that's the root cause. So some instructions on how to correctly load this motor were missing in an instruction manual, so it was set incorrectly. Very simple technique. See, if anyone who's got children, your kids probably do this to you all the time. Go tidy your bedroom. Why? That's what mine do anyway. So the Deming cycle and the 5 whys, I mean, they're very, very simple when you hear about it, but actually they're really powerful techniques to help you continually improve processes in your business. So that's kind of a potted history of lean manufacturing. But we obviously want to talk about software. So there's been a whole movement around lean software development. But unfortunately, certainly in like the consulting that I've done, a lot of companies don't really do anything with it, which is a bit of a shame. So the concept of lean software development came from a book called Lean Software Development and Agile Toolkit by Mary and Tom Popendiek. Fantastic book. It's quite a big book. It's not the sort of book you're going to read on holiday. Well, you might do, but you'd probably look a bit strange reading that next to the swimming pool. But this is kind of the manual, the Bible of lean software development, and it's a chunky text. And just like with Toyota, they've identified what are the wastes that we continually have to deal with in software development. So some of it feels similar to the manufacturing process. So obviously defects is a waste. If you have the defects go all the way through your process into production, and then your customers encounter that defect and start logging, incidents with you, that's a defect, that's a waste, that's bad. Building extra features that you don't actually need, we're all guilty of it. You think, oh, I'll just add this interface into this code because it might be useful somewhere down the line, but then you never use it. That's classed as a waste. You're building stuff that's not being used or actually needed, but it still requires maintaining, and it could potentially introduce bugs into another part of the system. But because you don't actually need it, you're not putting that much emphasis on it in the future. So this is how you kind of get problems building up in your systems. So handoffs, and this is doing handoffs between teams, departments, a bit like what Waterfall does. You have these documents and they go through these different handoff stage gates. It's like you're throwing documents over a wall at someone. Like, my bit's done, it's your turn. So doing any kind of handoffs between teams and systems can be considered a waste. Again, delays in getting your software released. So if you've written some code, checked it in, but you're waiting someone to do a code review on it, but no one's available to do a code review because they're all off doing the cool stuff of writing software. It always seems to happen. Code reviews are the kind of one of the least sexy bits of software development. If that code's just sitting there not being reviewed, so QA can't then go and do their thing with it, or whatever your process is, then that's a waste because it's just sitting there and it's not in the hands of the customer. Same for partially completed work. So if you're writing something or developing some code and then you get moved on to something else, and then that thing just never gets fixed because a priority, or never gets finished because a priority's changed, that's a potential waste because it could cause defects. If you do have to start looking at, if you do get pulled off onto something else that you're not supposed to be working on, sometimes going back to what you was originally doing involves a lot of context switching and task switching in your mind, which is expensive as well. So if you're in the flow and someone disturbs you and it takes you a good 15-20 minutes to get back into what you're doing, that kind of mental task switching that you have to do is considered a waste. And the final one is unneeded processes. So this is having process for the sake of process in your development process. It can be wasteful and just cause unnecessary complexity. So with these wastes in mind, the Lean Software Development Manual kind of talks about a series of lean development or lean software development principles. So we're going to look through each of these in turn. So we've got value stream mapping, which is probably where we'll spend the most time because it's very useful. Building quality in, amplify learning, decide as late as possible, deliver as fast as possible, empowering the team and seeing the whole. So these are kind of like, if you used to distill that entire 1,000-page book down into a series of headings, this is what lean software development's all about. And none of it's particularly complex. A lot of it's just what feels like common sense, which is quite nice. But the first one, and my favourite part, is what's called value stream mapping. So value stream mapping is a diagramming process that you can do as a software development team in collaboration with your business. And what this involves, it involves looking at a business process from start to finish and looking at all of the aspects of that process that add value to the customer but also decrease value to the customer or don't add any value. And it's useful in a few ways because A, it helps you understand how a business process works. It helps the business reaffirm to themselves how a business process works, and it gets you collaborating with the business as well, because you're not going to be able to solve it by yourself in a larger business context. You're going to need to work with the people that own that process. So I've got an example that I've done. I've taken two extremes, and this is from a real company that I worked at many, many years ago. And it's a retail finance company. I hope that's readable from the back, but I'll walk through it. So it was a retail finance company. When I worked with them, they hadn't really digitised a lot of their processes. There's still a lot of manual stuff going on. So this particular example is a customer wants to take a loan, then someone somewhere has to make a decision whether they can have the loan, and then the money may or may not get paid out to them. So I've done this as kind of a more extreme example, but obviously timings can be different. So a customer might apply for the loan. That might take them half an hour. And then, they post off a letter or an application form, because it was paper-based back then. So that could take anywhere up to 3 days to reach the company. Then it takes half an hour for someone to do a check, a credit check, an identity check based on what's been put on the application form. Then that gets sent off to another department, which could sit, in someone's in tray for up to 3 days. So the loan agreement is received, and then it's filed on the back end. Again, a quick task in itself, but actually having that loan being picked up, especially during a high demand period, say before Christmas, can take time. Then there could be another day's delay before the loan dispersal is requested, which can take up to half an hour. And then there could be like a half-day delay before the actual money is dispersed to the customer, and then they receive that money. So it sounds pretty clunky, doesn't it? It's a manual process. This is what banking was like in the old days, before computers really took over. So from start to end, the total cycle time was 207 hours. There's a lot of posting letters backwards and forwards between departments in different buildings. So a lot of postal work there. So that's 8 days. So from you applying for a loan to having that money potentially in your bank account, if you're agreed, is about 8 days. So the actual value added time, where actual good stuff is happening that's useful to your loan application, is about 3 days worth of work. But non-value added time is 204 hours. That's just wasted time where you're just waiting for stuff to happen. Posts to be delivered, letters to be delivered to in trays, that sort of thing. Which means your efficiency for that process is 0.9%, which I think you can all agree is terrible. But until you actually go down and map a process like this, I've picked a deliberately extreme one just to illustrate the point. But until you actually sit down with the business and start mapping this process out, it's difficult to see kind of where you can improve necessarily. So I've got another example here. So this is with an automated process that was put in place, using a lot of mainframes, but it's computerized. So customer applies for a loan online. That could take up to an hour, because we're expecting them to submit a lot more information, so we can do automated checks. That goes into a queue, so that could be picked up, say, half an hour later by a worker. Credit check happens, which can take, quarter of an hour, for example. Goes into another queue. Then the ID checks happen. Then it goes into another queue, which might take 2 hours, for example. So that could be an email being sent to the customer. It could take that customer 2 hours to pick that email up and sign like a digital contract, effectively. Might take half an hour, because they might actually read the thing first. Pretty sure some people read these agreements. They agree, they sign it. That goes off into another queue. Then the loan dispersal happens, and then, an hour later, the money lands in their bank account. So already it feels like this is a much more efficient process. So here, the total cycle time was 7.5 hours. The largest part of that was probably waiting for the person to either read their email and then probably wait till they get home before they actually do anything with it. because they might not necessarily do it while they're at work. So the value added time is 2.5 hours, and the non-value added time is 5 hours. So here we've got an increase in efficiency. It's still not very efficient, it's only 33% efficient, but we can instantly see that it's much more efficient than the original process. So I picked some extreme examples just to illustrate the point, but going through and doing this mapping exercise in your business on the processes you're working on is incredibly useful, and you'll probably end up with tens, if not hundreds, of these diagrams for different parts of the process. It's not until you actually look at what's delivering value and what's not delivering value that you can actually start to improve the process. So it's a very useful technique. So to recap on that, so it allows the developer to understand the process. It encourages collaboration with the business as well, because you need to work with them to understand their process. They own it, you're just developing software for it. But it also ensures that the business really understands their process, because a lot of the time they won't until they start doing some digging, especially if it's a very complex process that's been there for a long time in an organisation. You'll be surprised at how often businesses don't actually understand their entire process from end to end. So people only know bits of it that they need to look at. Okay, so the next principle is building quality in, which kind of goes without saying, but as software developers we're always trying to make sure we build good quality code. Now some of the things we might be used to doing is pair programming or mob programming if your organisations let you do it. A lot of companies don't. But pair programming is a good one because you've got two people sitting down solving the same problem at the same time, which is quite beneficial. So you've got two different perspectives on how to solve a particular problem in a piece of code. It's also really good, especially if you're working in a field that's safety critical. It kind of works like a maker-checker process as well. So one person's doing the code whilst the other person's checking what they're doing. And also test-driven development. I mean, none of these are new concepts. These are things that have been around for a very long time. But they're all about building quality into the software that you're deploying. But another thing that's very important, and is sometimes misused, but things like logging and telemetry. So we build these into our systems, but really the main reason why we're putting them there is so that we can detect when something's gone wrong. You know, we all have those dashboards and things like lighting up when something's gone wrong and we all react and run around in a panic. That's kind of the common use for logging and telemetry. But the other reason is to actually use it as a way of understanding what's going on in your process. So if you're measuring everything that's happening in a system, and then you have a way of actually taking all of that data and breaking it down, and effectively producing the digital version of a value stream map based on data that's coming out of your system, it enables you to learn what's going on in that system. And if you learn what's going on in the system, it means you have the ability to make experiments and tweak things because you have the data in front of you, which is quite good. I actually think there's a big gap in the market for machine learning systems that are just there to look at operational telemetry and help you make adjustments to business processes and optimizations. I think we'll be seeing a lot more of that. So that's a little tip if you're thinking of looking at machine learning. Another thing is, another process is Amplify Learning. And this is all about failing fast, you know, fast iterations and failing fast. And as an example that I absolutely love with this, well, it's a little controversial to mention anything with Elon Musk at the moment. But if we take Elon out of the picture and we just focus on his companies and look at SpaceX, for example, I think we can all agree that what SpaceX does is pretty cool with their rockets and the self-landing rockets and all that. But their approach is very, very different to the approach that NASA would take. So NASA is all about designing everything, having lots of companies check it, building, checking, experimenting, simulating. You know, it can take years before they're even at the stage of firing up a rocket, let alone sending it up into space. Yeah? So the speed that they learn is glacially slow at NASA. For good reason. Obviously they don't want people to die in their spaceships, which unfortunately has happened. But SpaceX's approach is very different, and culturally it's very different. Their approach is, let's build a rocket, let's launch it, it's going to blow up, let's find out why it's blown up, fix it, then try again. And the reason SpaceX has got to the point where they are now, that they're sending actual people up to the International Space Station, is because they went through that rapid iteration cycle. Built a rocket, blew it up, learnt from it, and did it again. It's the Deming cycle all over again. Yeah, that fast iteration. And it didn't take them that long to get from a point of an exploding rocket to a second stage booster landing itself on a barge in the sea, which is, I think, pretty amazing. But to feed off of that, it's all about amplifying learning. It's failing fast. You learn by failing. We do that in everything in life. You mess something up, you learn from your mistakes, and then you improve. And that was kind of a really good example of how to do that. So another principle is what's known as deciding as late as possible. And this is all about deferring tough decisions so you don't get blocked in your software development process. And I've got an example of this. I worked at another finance company, and we were changing the way in which we credit score and assess people to be suitable for a loan. It was a subprime lending company, unfortunately. So, we're probably lending to people that really shouldn't really be lent to. It was one of those sorts of companies. But they had a system called a scorecard. If anyone works in finance, you might have something similar. So the scorecard is where we go off, we do a credit check on someone, we get the credit check details back, and then we have our own set of rules that we go through to then determine whether we're going to lend money to that person. Now, our scorecard system was being changed at this particular company, but it required a lot of input from different departments and the legal team as well. And when you involve legal teams and lawyers in anything, it's going to take 20 times as long as what you need. So that wasn't compatible with the speed in which you're expecting us to develop this new system. So because we didn't know how the new scorecard was going to work, we had to defer that decision, but carry on writing the software. So what we did what any respectable software developer would do. We abstracted it, we created interfaces, we create a set of dummy scorecard processes. We knew what the outputs were going to be. There's 11 different results that could come from this system. So we just stubbed it in our own code. And then we had a little hack on there where if on the end of the person's surname you appended a colon and then certain codes, you could force different results to come out of the scorecard engine. So we went with that, and we worked with that for about 7 months while we're developing this system, because we knew that the actual scorecard rules wouldn't be ready in time. And then when they were ready, we had all of the infrastructure and the code around there to implement it. We just had to replace one small piece of code. So that's why sometimes delaying decisions until later and not blocking yourself is actually very beneficial. Next one is delivering as fast as possible. We've talked about this quite a few times, but obviously getting value out to the customer sooner is kind of your main priority. It's your customers you're delivering value to. Your customers may be business sponsors, or they may be end user consumers and the general public. But getting stuff to them sooner rather than later is what brings value into the company. And part of the way you do that is through teamwork. And expecting people to be flexible on teams. So the amount of companies I've worked at where people aren't flexible in their job roles, so if there's a particular bottleneck on part of the team, ideally you want people to be flexible and go and help out. So we've got an example I'll show later and look at Kanban boards, but we had in one example, you've got a block where you're expecting some manual testing to happen on a system. It was a healthcare system, so we had to do manual testing as well as automated. We had a particular block where we didn't have enough testers to get the code through, so we had to ask some of the developers to help out the testing team, and test stuff, not test their own code obviously, but test other parts of the system, because we were stuck and we needed people to be flexible. And the second to last one then is empowering the team, and this is very important. It's not just a lean thing. I think this should just be common sense in any company, but software developers and engineering teams are expensive. People command high salaries these days, so the companies really have to be in the habit of trusting their teams and empowering them to make decisions and not micromanaging them. And that's what this is all about. It's about not micromanaging your people. It's giving them the information they need, putting the necessary guardrails in place so they know what they can and can't do, and then just trusting them to get on with it, which is very important. Another part of empowering the team is making sure that your team actually has meaning through what they're doing, so they actually believe in what the company's doing. They're into the mission of the company. I've got an interesting example going back to this lending company I worked for. It's a subprime lender, so obviously we had a problem where a proportion of our customers weren't paying back their debts, which is obviously a problem for a financial lending company. So we had the woman who ran the collection teams was really forward thinking. She came up with a really good idea for an experiment. She's like, why, if we keep trying to chase these people, with those horrible menacing phone calls that you get when you're in debt, which nobody likes, it just puts people off and they stop answering their phone. So what if there's a way where we can encourage people to try and pay down their loans, even if it's just a small amount, on the promise that we're not going to harass them for 30 days. That was the premise of an experiment that we did. So myself and some other team members got together and we formed a little team which was running effectively as a little startup within the company, was given 2 months to implement this project. So what we came up with is, for these different cohorts of customers, so you've got people that are 30 days in debt, 60 days, 90 days, and then 120 days they're sold off to those debt collectors that start knocking on your door and start taking your telly. So those are the cohorts of customers that we're dealing with. So what we built, and this is all about empowering the team, was basically given the freedom to do what we wanted within a framework of compliance and legal. We had to work with compliance. But we built a portal. We had a way of communicating with the customers. They could come in, they could see how much they owed. So say they owed £500, for example. But then we gave them a very simple device. It was just a slider. It went from £5 and it scaled up to the total of their debt. Then as they increased the slider, this means you will pay down your loan this, X months quicker and you will save this amount of money. That amount of money equates to, cinema tickets and coffees and that sort of stuff. It's trying to do positive reinforcement about the amount of money that you'd save. But the important bit was, if you paid even just a small amount, I think the minimum was £5, the company will not contact you for 30 days. So we built it, we hooked it into a payment system, went through legal and compliance to make sure what we was doing was deemed okay. And then we started doing experiments. We contacted different cohorts of customers who were in debt, ranging from people that had just gone into debt, so they were within the 30-day mark, right the way up to people that were about to be sold off to debt collectors, debt collection agencies. And what we found was remarkable. So some people, just to stop the company from contacting them, would come in and they'll do a small payment. £5, £10, £20, which was quite remarkable. These are people that we couldn't contact who just don't answer the phone, generally, when you try and phone them. And we also found that people who are more severely in debt, further down that, 90 days plus, some of them actually came in and cleared their debts completely, which is quite interesting. So the customers, or the company tried to follow up with a survey with some of these customers. It was all an experiment, so we wanted to try and get their perspective if we could. And in a lot of cases, it came down to the fact that because debt is seen as a stigma, people don't like being in debt, they don't want to talk about it. So the promise of not having to talk to anyone and being given an easy way out of paying for a debt without having that awkward conversation was what was appealing to them. Absolutely fascinating. Bringing it back to empowering the team, it was me and 5 others were put on this little project to design it. We had a few months to do it. It gave us meaning because we were doing something good. We're trying to help get these people out of debt by giving them an easier way to pay. So we had meaning from what we was doing, and we felt empowered as well because the company actually trusted us to kind of design this system, which was a massive success in the end, which is great. How are we going for time? Right. So the final of the lean principles is called seeing the whole. And this is all about not just diving in and doing micro-optimizations here and there, because generally micro-optimizations don't tend to lead to big benefits. So seeing the whole is all about understanding the whole process that you're working within for the business. And then when you understand that whole process, then you can start looking at where you can optimize, which is what feeds back into the value stream maps that we looked at earlier. By producing those maps, you understand the process as a whole, then you can optimize the process as a whole instead of just doing small micro-optimizations. So one question that people ask then is, what do you do? Do you do Agile or Lean? Is it one or the other? So we've already looked at some of the Agile benefits, customer success by rapid delivery, interactions with people, high quality code, simple design, early returns on investment, all these things that we know from what Agile gives us, that we're all probably experienced with. And we know that lean software development is all about eliminating waste, running experiments, being more efficient, and empowering teams to make decisions. So when we talk about, do we do one or the other, is it Agile or Lean? The answer is both. can do both. I mean, most teams generally are doing some form of agile, or wonky agile, which is sometimes call it when it tends to be more iterative waterfall. But most companies are trying to do effectively an agile process to get code out to their customers quicker. But lean is kind of like an extra kind of layer of processes that you can do over the top of what you're already doing to try and optimize your businesses. So Agile and Scrum is a value driver software development framework. Scrum is a framework. It's just a project management template for running your team to implement Agile. Whereas Lean helps you optimize those frameworks and processes. So before we end, I just want to talk a little bit about Kanban, because this is used by quite a lot of teams, and it can sometimes get confused. So we talked before about the concept of the just-in-time development, which is, only doing what you need to do at the time that you need it, and kind of pulling your processes through, as opposed to being led by an arbitrary set of demands. So one of the techniques you can use is Kanban. So does anyone use Kanban or some form of Kanban board, either electric or physical? And it's a way of basically tracking the work that you do, but it fits quite nicely in with just-in-time development, which is kind of what it is designed for. So the way it works with Kanban is for each of your columns, so you might have, to do, in progress, code review, QA done as a simple board. You define for each column a set of work in progress limits based on the size of your team. So those work in progress limits are the maximum amount of tickets that you can have in that column before you start thinking that there's a problem. So if we look at this as an example, so here's a very typical or very simple looking board. Based on the size of the team, we set some work in progress limits. So we want no more than 2 tickets ever in to do, no more than 4 in progress, 3 in code review, 3 in QA, and then obviously done. You want to be thinking about releasing. So the team's working on their project, and we get into this state here. So can anyone see a problem on that board? Yeah? Yeah, so code review's got a work in progress limit of 3, and we're already at 3. So that board is screaming at you saying there's a problem. So the developers, they're busy, they're developing stuff, they're writing good code, and they're putting it into code review, but no one's code reviewing it. So the QA team has got 1 ticket they're working on, so you've got a load of underutilized people, and you've got a load of tickets building up. So if a development team keeps on going, they put that 4th ticket in there, you've not only hit your work in progress limit, you've breached it. And a lot of companies that use Kanban boards don't do work in progress limits. They kind of use it as a way of just, to-do lists or effectively tracking where tickets are. But by doing this, it's telling you that, your developers need to stop developing and they need to get on with their code reviews, because it's creating a block in that process. And that block is wasted time because the QA people can't progress, which means you can't deliver code into production. So if we compare Scrum to Kanban, and I know there's something called Scrum Ban, we'll come on to that in a moment. But if we compare Scrum itself to Kanban, so Scrum typically works in fixed sprints, 2 weeks, 1 week, 4 weeks sometimes, typically 2 weeks. Whereas Kanban, it's continuous flow, so you're not working in sprints. You're not having sprint planning meetings every 2 weeks. It's a continuous flow of tickets that are coming through the board. So it's continuous planning, continuous development, continuous flow. Scrum typically, ideally, you want to be releasing at the end of every 2 weeks. I know that's not always easy in some large organisations to release every 2 weeks into production, but you should be releasing somewhere that your business can actually start playing around with. Some kind of UAT or approval server is normally what happens, and then you get your larger releases further down the line. But with Kanban, it's continuous flow. So the nirvana for it is that as tickets go through to done, your continuous process, your continuous delivery pipeline will just completely push these things out into production. That's kind of the ideal. Doesn't always happen, but it's what we aspire to. Scrum has defined roles on the team, so you've got product owners, Scrum masters, you've got your development team. Very defined roles as defined in the Scrum user guide. But Kanban, there's no existing roles, everyone is on the team. Sometimes you might need developers to help out in testing. You might need people to help business analysts out sometimes to define tickets and stuff. It requires that people can be flexible in their job role and not just necessarily do their one role. Scrum, the key metric is velocity, so it's how quickly you get your tickets through the board in a sprint. That calculates your velocity, and that tells you roughly how much you think your team can handle in the next sprint. Whereas in Kanban, it's all about the cycle time. So at the point that ticket comes in from to do into in progress, how long does it take for that ticket to then get into production? Not to done on the board, it's, when has the customer physically got that ticket? And you're always striving to reduce that cycle time as much as you can. In Scrum, typically when you're doing a sprint, you don't normally make changes to the sprint. You normally let the sprint run. There seems to be several schools of thought on this. So if you take the Scrum manual to the letter of the law, then you would never break a sprint. You'd always get to the end and then you'd replan. I've always been a bit more flexible in that with teams I'm in. If the business comes to you with an emergency and you have to repivot the team, I personally agree you should just end the sprint and replan. But I know that can be a bit controversial. But typically, you wouldn't make changes mid-sprint. Whereas on Kanban, changes can happen at any time. Now, Kanban does sometimes get confused, and what actually people do is something called Scrumban, which is, it's not continuous flow with a Kanban board, it's just using a Kanban board as a way of tracking where tickets are in a sprint. So typically, you work your 2-week sprint, and then at the end of the sprint, you clear the board down and you start again. Or open the window or slam the door and all the tickets fall off the board. I've had that happen quite a few times. So that's one way of working. If you're doing Scrumban, you're not typically setting work in progress limits, I've found. You can do. But in my experience of working with teams, that very rarely happens. But Scrumban is kind of an adopted kind of term for a bastardized version of Kanban, where you're using it just to track tickets in a sprint. Okay, so we're pretty much at the end. So as a quick summary then, so lean software development is all about trying to eliminate waste from your software development process. So defects, extra features, handoffs, task switching, partially completed work, that sort of thing. And we do that via a series of lean principles. Now, I hope you'll agree that none of these principles are actually that complex, really, in what they're talking about. I mean, when you get Mary and Tom's book, I mean, they go into a lot of examples, which is what makes the book really big and good, but really what it's boiled down to is these few simple principles as a way of running a development team. So value stream mapping, building quality in, not just using metrics, logging and telemetry to find problems, but actually using it to assess how a system is running and looking at the health of the system. Amplify learning, deciding as late as possible, delivering as fast as possible, empowering your team, and then optimizing the system as a whole. We've also discussed that lean is something you can do alongside Scrum. It's a way of optimizing what you're doing in Scrum. So it's not Scrum or lean, it's something you can do as well as, which is quite good. And we finish up there just by looking at some differences between Scrum and Kanban. So I hope you found that interesting. I appreciate it's the end of a conference. Some people have been here for 5 days. Did anyone do a workshop? So you have people done workshops, you've done 2 days of learning and then 3 days of conference. That's quite hardcore. So thank you for making it to this talk. In the speakers, we joke that this particular shift is called the graveyard shift of the conference. It's kind of a bit hit and miss how many people are going to turn up, but everyone has to do a graveyard shift at some point. It was my turn this time. Okay, so thank you very much. If you are on Plural's site, I've got some, I hope are handy courses that can help. So Agile Fundamentals is really good for people that have never worked in Agile before. Particularly good for non-developers as well. So if you've got project managers, business analysts and people like that that are looking to move over or learn about Agile, that course is particularly good for them as well. And then the sibling course to that is Lean Software Development Fundamentals, which kind of goes into a lot more detail than what we've talked about here. There's lots more worked case examples. So again, I have books out if you're interested in such things, if you like reading. I quite like typing, so I like writing books. It's quite handy to do over lockdown. And thank you. You can find me on Elon's Town Square at Stephen Haunts. Thank you.